Morning, good evening, good night. Welcome everyone for the bootcamp. Welcome everyone for lesson 10. We're going to build a smart contract together today. We have a challenge to complete together today and tomorrow to exercise building smart contracts, to exercise using this environment that we have, using hard, using the tests, using scripts to guide us into building a smart contract. Because on Thursday, we're going to build a tokenized ballot. We're going to understand how to use the components of OpenZeppelin, the ERC20s, 721, all of those ERC to work together to create smart contracts, okay, to compose things ourselves. So far, I have been showing the tools, showing you how to use them, showing the build blocks. Today is the first time that we stop and do an exercise together, challenge together. Okay, the smart contract itself, this TokenSale.sol is not that important. It's not doing anything important. It's not like a DeFi protocol, whatever. It's more for us to learn the technique, the flow of work, and getting started and understanding a project, understanding, let's say you are doing freelancing work or you have a job on coding these things. You're going to understand requirements from your client or from your boss, or from the project manager, whatever. You're going to code the unit tests to see if they are making sense, and then you're going to start coding the smart contract, okay? So this is the flow that we're going to follow today, and you can follow the same flow for things that you are building in the future, okay? It's great for collaborating, managing like workflow, what features are done, what are not, which ones are not done. So it's going to be helpful for a lot of different reasons, okay? If you still prefer to code with like cohorts, whatever methodology that you want, that's okay too, don't worry. Just remember that smart contracts can't be fixed later. If you have a bug, if you have a problem, you cannot roll it back that easily. There is an upgradability pattern, but there's another thing. We're going to see that in lesson 23. So the more care and caution that you take when developing, the better. Okay. So do you remember about how to use VM hard, how to write smart contracts with it, how to do those tests, how to deploy smart contract, how to get wallets? Remember week 1, the syntax of solidity, how to build a smart contract, how to do an external call, how to do operations. We're going to review it all today, building this challenge together, okay? We have this explanation for this smart contract. We are going to have one contract called TokenSale.sol. And this contract is going to have a set of features to manipulate other tokens. For example, Uniswap that we used in lesson 1, it would be able to manipulate 2 tokens, right? It would put 1 token in, it would get another token out by swapping. We're going to see more of how it works in future weeks. But we have those smart contracts that can interact with all the tokens that are all the smart contracts, right? So today we're going to see those patterns here. What are those common patterns? How to do the external calls, how to do divisions, today and tomorrow we're going to see lots of it. But this smart contract token sales is going to interact with all the tokens. So anyone could buy an ERC20 token that is going to be minted on the fly, okay? Anyone can buy by sending ETH to that smart contract, and the conversion is going to happen by a fixed ratio. Ratio R means that 1 ETH should buy R tokens. And we're going to see that there is a problem here with ratios. Anyone can then later withdraw ETH by burning those tokens at the contract. So I can mint and burn those tokens like we saw yesterday, right? We could mint these tokens using a minter role or access control. We're going to do something similar today. When I have those tokens, let's say I put 1 ETH to buy 10 tokens of the contract. When I have these tokens, I want to purchase an NFT for a configured price instead of a ratio. And we're going to see that prices are much better to work than ratios because of the divisions things. So if I have those 10 tokens, I can buy one NFT for a price P. Okay, one NFT should cost like 2 tokens or 5 tokens, something like that. Okay. When burning the NFTs, I would have this function there to burn the NFTs. I can recover half of the purchase price back, and half gets kept there at the smart contract, so that the owner of that smart contract, the person who deployed that smart contract, can withdraw this amount, half of the NFT sale, whenever an NFT is sold. And the owner can go there and withdraw this money, only half of it. Let's say the price is 5. So the owner can withdraw 2.5 of these tokens, and the person who bought that NFT may recover 2.5 later. Okay. So there is a money flow from ETH. I go to the token. From the token, I go for the NFT. The NFT I can burn to receive back half of the tokens that I paid, and then I can burn these tokens back to half of the ETH that I put. Okay. So this is the challenge explanation. Questions here? Let me draw some things. So I'm going to have one smart contract here that is going to interact with the ERC20, and is also going to interact with the ERC721, right? Good. It can mint, and it also can burn those 2 tokens based on some logic, correct? And also there is one operation to be done to keep half of the purchase price, because half the user can burn and withdraw, and half the owner can withdraw. So there are those 2 logics. Going very slow, just so that everyone understands the idea here. Again, this is not doing anything super useful. It's not a financial protocol or anything like that. I have a question from Ulatsmi. Yes.
I have a question about this logic. Once the user born his NFC, user will get the half of price, and other half will get the contract owner.
Yes, yes. Half of the value is going to be kept there so the owner can withdraw. The owner doesn't need to withdraw all the time. It can wait. For example, it can wait for 1, 2, 3, 4, 5 sales. When there is enough money there, he can go there and withdraw, okay?
And the owner can withdraw only half of that.
Only half of the sales.
I mean, for example, user pay $100, for example. When he burn his NFC, he gave $15, and other half we will get the contract owner. Yes, and
Yes.
and he can withdraw all this sum, not 25, but all this sum. Yeah.
Yes, if you pay $100 for the NFT, let's say the price is 100, and then you burn the NFT there, you can withdraw 50 on spot there, and the owner is going to have 50 kept there for him to withdraw later. Okay,
Okay, yeah, great, thank you.
good. I just got to ask you a question in the chat. If we're building all of that under a single smart contract, we're going to see that. We're going to do an architecture overview to ponder if should we implement all of that inside a single smart contract or no. And we're going to see why we are going to need to divide in different smart contracts and do external calls. Okay, before we go there, Ivan and Corrado, you have questions? One at a time.
So I kind of look at the description of the challenge that you are having there. And for me, it's in a way abstract. I guess towards the end of the lesson we'll understand. But at this point, I don't have much experience in tokens or NFTs. And for me, kind of conceptually, I have difficulty picturing kind of what would be the idea for this set of features to be done. Like, okay, I have in mind to, I don't know, sell 10 pictures, and I would like to structure them as this, and, you know, kind of very abstract.
Okay, you want to
But have to play.
conceptualize this in something more visual, like a real world example.
Yeah, not visually in terms of maybe that eyes can see, but somewhat that I can understand the logic why somebody would want to do that. But maybe we will just get there while we are working on it. But
Yeah,
if you
as I
can
said,
show an
this
example,
TokenSale.sol is not doing anything that useful at all. It's more to exemplify what kind of operations we're doing here. But it is resembling some common features that we see with tokens. For example, imagine NFT sales, um, like those bored apes, the penguins, and all of that. Those that you have, you can imagine a normal artist. You can imagine like an IP brand like Marvel. They want to sell an NFT. They want to sell unique pictures that you can prove that are yours. So they can sell by dollars, they can sell by ETH, or they can create their own token to sell the NFTs for these tokens. It's possible. Okay. And here we are wrapping one ETH into those tokens just to make it simple. So it's going to be some sort of wrapped ETH that we can use to buy these NFTs. If you want to understand this thing here, imagine as a rebate. The floor price for your NFT can be 50%. So anyone that buys an NFT for like $1 million knows that at least 500,000 they can get back. Sometimes this is a good feature. Sometimes the floor price of NFTs can go down to zero. So the examples to resemble real life examples would be something like this, okay? The examples, sorry for you. I should have explained that better. Okay, but if you're looking to something more real, like, oh, then this is a very useful smart contract. This is not the case, okay, Ivan? It's more to explain the underlying techniques than actually to do something financially useful here, okay? Conrado, your question.
Yeah, my
Yeah.
question is about the burn. You are just transferred to another address you can get, or you are just delete from the file, or how can you explain to me?
Yeah, burn is going to remove those tokens from circulation so that no one can use it anymore.
Okay, so in the another half, you just the another half the price is just the token to the NFT, it's not the value, right?
Yeah, let's do that with numbers. For example, I put a 1 ETH to get 10 ERC20 tokens, right?
Right.
Now, if the price is 5, I have 10 tokens. I will pay 5 to get 1 FT. Now I have 1 NFT and 5 tokens.
5 tokens. Okay.
If I burn my NFT, I would have 0 NFTs and then
2.5.
7.5 tokens because I had 5 already. Now I
Yeah.
have 7.5, and 2.5 are stored there for the owner to withdraw later.
Okay. Okay.
Good. Yes, a burn is the opposite of mint. have went through the references of the last lessons of yesterday, actually. We have these things there in the ESCs, but we're going to see them today and tomorrow again, so don't worry. So let's start with a project. Let's start with the project 5 that I have here. I'm going to copy everything except the node models. I can get artifacts and cache out too. I could just clean them later too, don't worry. And now I'm going to create a new folder called TokenSale. Okay, you can name this folder whatever you want to. And I'm going to paste these files here, and I'm going to install everything. Do npm install because it's way quicker than moving the node models around. And I'm going to do a command called npx hard compile just to make sure that I have everything working, okay? Copying from yesterday's lesson from project 5, I should have the ERC20 and ERC721 smart contracts there, okay? Just check that. Less contracts. Yes, my NFT, my token, they are there. Okay. So I'm going to do an npx hard compile to see if things are working. And if it compiles, okay, it compiled, so it is working. Okay. Arada, you have a question?
Yes. So when we look in the JSON files in our project, for example, package.json, we're going to see that the name of our package is ballot, for example, because we started copying from there. Is there any easy way to correct this using Hardhat, or do we have to manually do that?
Yeah, this is when you do npm init. Let me see what I have in my package. For example, my name is project 2 since since today because I've copied over project 2 back and forth. So you can just come here and change for example, I'm going to put oops. I'm going to put let's shift go here. What did I pick? Wait.
You are not a BI user.
Yeah, my keyboard is messing with me here. Let me do another. Because my delete key is the same key as the insert key. So yeah, it's not doing well here. Let's name, for example, token sale. Okay. This is just a metadata configuration, okay, Arda. It's not anything that important because we're not going to turn this project as an npm package or something like that, okay? It's not necessary, but this kind of attention to details is very appreciated. We have a lot of documentation, a lot of code out there that is messy. So whenever you take your time to go there and properly name and organize things, it is very appreciated. Okay. Every time you have a little disorganization, it is a technical debt. It might take 2 seconds to solve, but it's there piling up, piling up, piling up. Okay. For me personally, it consumes part of my brain, of my attention. So and I like to do this kind of things. Okay. Everyone ready? We have our project. We can list the files there. I have every file. I can do npx hard compile, and it's working. Okay. Yes, Browns? You have an issue here?
Okay, no, a question. Okay, so for the token sale contract we're going to be writing, are we going to, yes, I know you made mention of using NFTs and all of that, but I noticed that those, because I know they use some of like,
I guess we lost you, Browns. It was on my side. Hello, hello. Okay, okay.
No, I can't hear.
Hello, Browns. Okay. This is connection cut. Let's keep on going. When Browns returns, we get to his question. So let's create a new smart contract here called TokenSale.sol. We touch contracts. Actually, let's do that from Cursor, okay? Let me open this folder in Cursor. I'm going to have two different tabs open. And remember, I'm using Cursor just as I'm using VS Code. I'm not using the AI features or anything like that. It's just a normal IDE for us, even though you can use the AI part for asking questions, for generating code for you. For now, I'm just using it as a normal IDE, okay? Lauren, do you still have a question? I see your hand raised there.
Yes. When should we compile? When we create a .sol or also when we create TS files, so TypeScript files?
Yeah, Hard is not going to compile TypeScript files, just Solidity files.
Okay.
So anytime you have a change in a Solidity file, you can do the compile. Okay. Here I'm compiling just to see if my project is working, if my setup is correct. So this is why I did the hard compile here. It's not necessary, just to test things out, okay?
Okay.
Okay, and I'm going to create this new contract here called TokenSale.sol. Okay. So I should start with a Pragma Solidity identifier, Solidity 0.8.28, something like this, or anything from this to above. Okay. The license identifier, I can pick MIT, whatever I want, and I can start my contract, token sale. Okay. These editor shortcuts, like do Pragma and have a code block, do contract, hit tab, have a code block. These are very useful for you to get a user to it, accustomed to it, like it becomes like a muscle memory at sometimes. The IntelliSense, using the correct extensions, using TypeScript to have hard-typed things later, it can help you a lot to gain speed and accuracy when you are developing, okay? So that you don't mistype or mistarget anything. Get used to this, hitting tab to autocomplete, to auto-fix stuff, okay? So this would be the initial state for that smart contract. And for today's lesson, tomorrow's lesson, I'm not going to say much. I'm going to ask for you all, and then I count on you for helping me here, okay? All of you that have been interacting the past lessons, Laurent, Ivan, Arda, Pedro, all of you. So if I forget one of your names, Marco, Conrado, all of you that have been interacting the past lessons, plus everyone else that wasn't interacting, I count on you today and tomorrow for guiding me through this challenge, because the point of this challenge is for us to do together, for us to think on ideas together, for us to think on bad ideas, for us to think on good ideas, all of it together. Okay, and the bad ideas are even better than the good ideas because they show us possible paths that can go wrong, and then we learn from it. Okay? Did you know, people, that errors are precious? Mistakes are super valuable because you learn from them. Okay, so let's put ourselves to try things here, even if they are wrong. Okay. So let's start with that question we had from Edgar a while ago. This contract is going to manage an ERC20 and an ERC721, right? So what if I make it like this? Is ERC20 and ERC721 from OpenZap, for example. Let's say I'm going to import ERC721. Here, I'm going to import ERC20 here. And I'm going to make my contract ERC20 and ERC721. Oops. No, I'm doing it in the wrong place. Sorry. Now it's correct. So I'm going to make my contract ERC20 and ERC721, for example. What do you think of this? Would it work? What could go wrong here? Laurent,
I don't want.
talk to
I
me.
don't think we want token sales to be ERC20 and to be ERC721. I think we want to store inside of the contract both. No.
Yes, that's true. Why are we going in that direction? What would happen if we made this contract ERC20 and ERC721?
But I think we have we need to burn some ERC20 and to create some 721. So if we burn the ERC20, it will burn the token cell and everything is linked. So it has to be delinked somehow.
They might be conflicting some ways, right? Arda, Dante, what do you guys think too?
This constructor would not know which constructor of ERC20 or 721 to call.
Yeah, we need to do some weird override, right? And here, I mentioned it very quickly. ERC20 is the base most, and ERC721 is the most derived. So, for example, both of these, they implement functions like balance of, like name, and now. What would happen here? Would be very great. Dante, you want to go before we keep explaining?
Well, I think I was gonna say the same thing. Like the in the constructor, don't you have to pass in the ERC20 information and then the NFT information, and then I guess maybe open up a function to do something.
Yeah, I would need to implement
I just
these
remembered, by the way. Yesterday you said the order of inheritance would matter because it would override. So this would call ERC721s.
Yeah, I could even do both, but a lot of functions that would overlap. Because ERC20s, they are not designed to be compatible with ERC721s. It is possible to combine, for example, ERC20 and access control. We saw that. But ERC20 and 721 is not compatible, okay? I can have a cat there is a white cat, a black cat at the same time. Okay, I can have a cat that is lazy. I can have a cat that is strong. There are some features that I can combine, but I cannot have a cat that is a dog. You see? So there are some definitions that are conflicting. If I say that my contract is a cat and is a dog, probably is going to bark. It's not going to meow. It's going to be a good boy, not a. I love cats. It's just that I'm picking the stereotypes here. I do love dogs a little more, but you got the idea. Whenever we inherit from other contracts, this can have heavy implications to what I'm doing. So I see a lot of projects like this. Every bootcamp at the end, we have projects where a contract is inheriting from token. No, don't inherit from a token unless you're doing a token. Okay? If you're working with tokens, we are going to do external calls. And I know that they are expensive. I know that they are complex. I know that they can open security problems. Yes, but you need to do it properly. Okay. There is a whole part of today's lesson of this challenge explaining this pattern for doing external calls. Okay. One contract is going to call the other. This is very common in blockchain development, in smart contracts and all. Contracts should be composable and modular, one calling the other. Okay. DEXs are like this. Lending protocols are like this, games are like this. Do create a lot of smart contracts and have them call each other. Okay, this is a much more organized and safer way to do things. Where to draw the lines can be a little tricky. Where to divide a smart contract and where to put in the same place, it can be a little tricky. But with some architectural care, we can draw these boundaries well. See, where we made the smart contract, where we made a external call, no, we can get these answers from the architecture itself. Okay. Browns, you have a question? I see you're back there.
Yes, yes, I have a question. Sorry for the network issue.
No worries.
So my question is, okay, they were talking about the constructor when using ERC20 and ERC721. Yes, yes, exactly. So my question is, if say you want to, or for example, is it possible that you put ERC721 first before ERC720? Or is because ERC20 is a parent, I'll call it a sub-parent to ERC721.
This is more because the token sale is not a token. It's a contract that sells tokens. So inheriting a token contract here would be much more weird, much more prone to problem than actually doing those external calls, you see?
Yes.
So that's a very common confusion. Whenever using tokens, it's very common to see people inheriting from the ERC20 protocol. No, actually, you might want to deploy the ERC20 separate and then use it here inside the smart contract, okay?
Oh, thank you.
Is that clear for everyone? It's like 1/3 of the things that we need to learn today is this architecture, having those external calls in place. Okay. So I could go coding my smart contract token sale here on top of my head from what we have in the description. So we should have a fixed ratio, we should have a fixed price. I could remember from what we saw in those other smart contracts, and I could have like a UINT 256 UINT 256 ratio, UINT 256 price, and then I would go thinking on top of my head, and I could get confused and all. A lot of people do like this during hackathons and all. They try to code everything in the smart contract, and then they realize that they coded much more than what they needed. The the input parameters are not correct with what they want to input and output on each function now. So I do not suggest going this path of writing the smart contract directly, okay? Because every line of code here is heavy. You need to understand a lot of what is going on behind. There are a lot of security problems and all that can go in now. So I'm not going to code the smart contract directly. I'm going to first write the tests. So I'm going to write TokenSale.ts inside the test folder first. And I'm going to start with the scenarios. I'm going to write down the scenarios. I can even ask AI, write down the testing scenarios for this challenge here, and then I can think with my human brain too. So this would guide my development flow. This set of tests. Okay, we saw that in lesson 5. These tests can be human readable. I mean, like non-technical, can be human understandable, much more than Solidity code and bytecode and all. Can be understood by non-technical people. And it is also going to give us a sense of progress. Let me refresh those tests here. I can remove that all the test file just to reduce confusion. So I can run these tests here, all of these tests, and all of them are going to be failing, of course, as designed. And this can give us a sense of progress. The more we have passing, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 of those passing, we can say that we are 10, 20, 30, 40% done with our smart contract. See? So this can guide our chain of thought or process of designing that smart contract. So we have this case, when the shop contract is deployed, you should define the ratio as providing the parameters. We should define the price as providing the parameters. You should use a valid ERC20 as a payment token, a valid ERC721 as an NFT collection. When the user burns an ERC20 from the token contract, what should happen? It should charge the correct when the user purchases an ERC20. So it should charge the correct amount of ETH. It should send this ETH to the smart contract. It should give the correct amount of tokens back. Yes, we expect those things to happen. So we have them here in the test file, preparing us for coding that smart contract. Okay. Questions about this structure? We understand what is going on? Marco, I suggest this methodology for academic purposes because it's going to be super easy to understand what's going on. You can pause, you can do a breakpoint, you can also log things, and also it's great for building smart contracts because we build all smart contracts in the factory like this too. Okay, and I don't see this very often. It's not very common for people to do this methodology like test-driven development methodology, you know. Because we have in software development, we have this practice of moving fast and breaking things and blah, 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 like Facebook and all that. And which is great for software development on front ends when you are doing something quickly to test with your end users. Yes, but for smart contract, this is crazy. It can give like a lot of bad results for your project, can make people lose money, can get you in trouble. So all of this vibe coding and all for smart contracts can be dangerous. I'm not saying that you should do the test before everything you do, like your front end, your mobile app, and all. But for software development on blockchain, I do advise. Okay, it is an opinion that I have. Some people do agree with me on this. Whenever I see people using that in hackathon projects, they spend like 1 hour on this and they have huge advantage over the competition. So I've seen that in practice enough times to say that this is a good idea, especially for teaching, as we are going to do today and tomorrow, and as we did in some past lessons. But for development in overall, I would suggest you for doing all of your projects like that. Okay? It's going to pay off very well. Okay, so this is the test file. Okay, Bronze. This is the TokenSale.ts. It's a test file. Everything is failing as intended. Okay, we designed it to fail from beginning. And we're going to slowly code the TokenSale.sol to pass for all of those tests. Okay, we can write directly for this test, and then we can refactor for a better code. And this creates like a constant flow of development. Okay. Good. Let's do the first one. First one should be very easy. Let's develop it together. So when deploying that smart contract, I want to have the ratio as defining the parameters. For example, I can have like a const ratio equal to 10 and const price equal to 5, something like that. I want to pass those for the smart contracts. Would you suggest any way for us to do that? Now the ball is with you. I'm not going to do anything unless you tell me to.
Maybe we should read these from the contract itself somehow.
The contract itself. So we need to do something like that. Let's make a to-do here. We would have a ratio, const ratio, equal to, we would have something like a token sale contract, and we would do a dot, we would await a dot read dot ratio, and we would expect ratio to equal ratio, something like that, right? Okay. Suggestion here from Conrado to create a load fixture. That's a good suggestion too. Do you remember how to create the fixture? You have to deploy the contract first. Yes, for example, creating the fixture. You remember where we used it in the past? Maybe we can copy from there.
In
Maybe
Hello
don't.
World.
Yeah, we did that in the Hello World. That's correct.
The ballot contracts.
In the ballot too, yes, we could open any of those projects that we have. For example, project 4, project 3. So this is why I suggest you to have those on your machine separate. For example, I have this test file, ballot.ts, where I had those code snippets there. So I can copy this load fixture. And it's okay, people, to forget things. You don't need to remember all of that on the top of your head. And then we would have a deploy contract, something like this. Okay. Remember? So Conrado, Trust, the suggestions are good. We need to deploy the contract first. I'm copying that from the ballot. Okay. We can open this on course or whatever place you want. You should have it there. Yeah, I want to get you user to this. So I'm getting a public client here, deploy order account, ballot contract. Well, let's change this line. Instead of ballot contract, is going to be the token sale. And what parameters should we pass for the token sale? It is this proposals map. No, right? What
The
parameters
ratio
should we
and price,
pass for it?
ratio and the price.
Ratio and the price. Okay, can give a minute for you to code this on your side too, understand what is going on. And then we would import here, we would need to fix some things back and forth. There's a lot of back and forth involved here. Okay. Naya, you asked or you commented here earlier that we don't have the setup for the contract with the return variables we would use. Yes, we are going to create it right now with this flow. You thought very correctly. Raise your hand if you got lost here in this step. We got this load fixture, as Conrado suggested, from a past exercise that we did. Now we have the load fixture here. We have this function deploy contract for us to use. Raise your hand if it was too fast, if you got lost here. Okay. Go back for, yeah, so here we have, we were doing the first test scenario, okay? And then we got the idea that we need to compare the ratio that we have from the contract with the ratio that I have in this variable. Let me do Control Z. So we got this idea that we wanted to check ratio with ratio that I have from the contract on there. But then we thought we need to deploy the smart contract first for us to do this line 11. Okay, so then we are creating that fixture. We should deploy that contract. We still need to fix more things, but we are going the direction of comparing those two. Okay. So to read this from the fixture, I could say that the const token sale contract equal to load fixture bypassing this deploy contract function. And then I'm going to have the token sale contract. Then I can compare those two, right? I could load more things from the fixture. Here, I just need the token sale contract to see if the ratio that I have passed here is the same ratio as I have inside the contract. Okay. I'm going to compile my smart contracts now. I'm going to compile TokenSale.sol. And just by using TypeScript with this set of packages with VM here, or if I was using type-chain types with ethers and all, just by compiling the smart contract, I'm going to see some of the problems. So I'm going to compile from here, from my extension. That would be the same thing as compiling from the terminal. Okay. You have questions, Arda?
Yeah, in the constructor of the token sale, we didn't set the ratio and price, so it's automatically going to give an error anyway. I mean, not
Perfect.
right now, but
Exactly now. As you were speaking, I was compiling my smart contract and now we have this problem. We don't have a token sale with 2 arguments. Okay, exactly this. So how to solve this? How would we solve this in the constructor?
We implement constructor with 2 uint arguments
Perfect.
and then set.
Let me do it wrong first, and then you tell me what I did wrong. So I'm going to say that ratio equals to ratio and price equals to price.
Yeah, I mean, that's why we generally write the parameters with an underscore starting the variable name, right?
Yeah. Let's see that in the test, because I'm going to show why the tests are useful. So maybe we overlook this problem. This is a very obvious problem, but maybe abstract as this as a problem in smart contract that we couldn't see yet, something that's not that obvious. And we are passing this as a parameter. So I'm going to compile my smart contract again. And we are passing ratio and we are passing price, expecting the contract to store those two, store ratio and store price. Okay. And we're going to see that we have a problem. Let's get there slowly. Okay, Abbas, you had a problem, or you had a question actually?
Yeah, I just wanted to ask how you brought out the option of compiling within your IDE.
Yeah, Ctrl+Shift+P or Command+Shift+P. It's using the hard extension, and then you start typing compile. You are going to see this option here. It's the same thing as using the CLI. Okay. Now, 2 things for us to solve. First of all, the parameters, they need to be big numbers all the times. So ratio cannot be 10. It needs to be 10n. Price cannot be 10. It needs to be, it cannot be 5. It needs to be 5n. Okay, we need to use big numbers all the time. So we're going to see that mostly tomorrow. JavaScript cannot handle these kind of numbers. Okay, we need to put them as a big number notations. Okay. Token sale contract here. So token sale contract is going to be like this. Contract. So I'm going to, another thing. 10n is a big number. Okay. 10n is a big number. We're going to see those in a little while. Okay, and another thing is that we should make the uint 256 ratio and price as public, right? So that we can read the state of these variables. So 2 things that we need to fix, the big numbers and the visibility for the ratio. Okay. And sale contract. What did I do wrong here? No, it's correct. The ratio cannot be float. We're going to discover that today. There are no floating numbers in Solidity, actually in the EVM. There is no float in the EVM. EVMs need to be deterministic. Floating are a mess. So the result of divisions or anything you do, it's always an integer. Okay. So the result would round towards 0. So any operation that you do that would result in a float can give you problems. Okay. This is why we're going to see that prices are much better than ratios. Okay.
Here ratio is uint 256, right?
And right now it's just a
contract.
number, but it is stored as a uint 256 in the contract.
We are writing a line where token sale contract dot read dot ratio in brackets, right? So
Here.
that read also reads any integer, or it only reads a function?
It reads functions, okay? So here, since we marked the Win256 ratio as public, it's going to create a getter function for us. And we saw that on lesson 4. Whenever we mark a variable as public, we can get the function for them.
Oh, okay.
Okay. So let's do a debug here, breakpoint. Let me debug this test. Let me compile my smart contract first. Just make sure I have the correct version. Now let me debug this test. So that I can inspect what is going on. So token sale contract was deployed in this address 0x5fbdb blah blah blah. I have defined ratio as 10 and a big number. Okay, but the ratio that I'm getting from the contract is 0. You see the problem here? The test could get this problem for us. The test could detect that the ratio is not being saved. We did something wrong in this smart contract, and the ratio is still 0, even though I passed it here as 10 in the constructor. Okay. This debug console can be great for us to study things too. Okay. For example, here we can do operations. What is ratio? It's 0n. Okay, we can do things from here. Like, how much is 1 plus 2? 3, right? How much is 0.1 plus 0.2? Do you know?
Generally undefined.
Or on JavaScript? So you can choose node, compile with C.
It depends on the system, exactly. Rounding is tricky.
0.1 plus 0.2 is not equal to 0.3. 0.1 plus 0.2 equals to 0.3. False. Yes. This is a problem. This is floating number because the computer is working on binaries, binary basis, base 2. And 0.3 is not defined in base 2. It's defined in base 10. We can define it very well, but it's not very well defined in base 2. Okay, so we have these problems. We're going to see all of that. The debugger is your friend here. You can pause and you can know what kind of madness is coming here. If you are new to computer science, half of the problems of computer science are invented by the computers itself, okay, by math, by using base 2 instead of base 10, base 16 and all. So having a way to separate what is a blockchain problem to what is a computer problem, it's good here, okay? So now we have this problem that the ratio is not equal to ratio. Looking at the smart contract, it's very obvious why. We obfuscated the variable ratio with this. And there is no way to have like this dot ratio like TypeScript would have with classes or other language would have with classes. No, everything comes to the same place when doing the program here. So it's very common to shadow variables in definition. So this is why we usually do this underscore for things that we are receiving to preserve the things that we have already in the smart contract and avoid shadowing declaration with the things that we are receiving. Okay. Yes, Naya?
2 questions. First, do we always have to initialize the contract with the state variables?
Do you mean here the constructor?
Mm-hmm.
Just when you need that. Just when it's an initial configuration or something on your contract, not always.
Okay. And then why do we not set I guess, an initial number or anything, do we have to leave it as like the underscore name to make it flexible?
So you're asking why we put the underscore here, or why didn't we set a value like this? So it's one of these two things.
Yeah, I think I guess I'm kind of asking both.
Yeah, so we want this token sale to be flexible so people can deploy different token sales with different parameters, like the ballot. Remember, in the ballot, you would be able to deploy different ballots with different proposals without altering the code, remember? So here we have a token sale where people would be able to configure different ratios and prices for their own instances of token sales so that we don't define in the code itself. See?
That makes sense. Thank you.
Okay, good, good. Good. So by doing this, I would solve the first unit test. I would have it passing. Now, actually, I need to compile. You see, people, when you change the smart contract and you don't compile, it's not going to be auto-compiled by the tests, okay? You still need to go there, compile yourself, and then you're going to see it passing. Okay. Okay, it works. Don't you have a question?
No, I just wanted to clarify like that anyone when they're using the contract will be able to input in that instance the ratio and the price, right?
When deploying, but not after, okay? So this is the advantage of using a constructor function. It can only be triggered on deployment. After you deploy that smart contract and people are using it, the ratio and the price, it's going to be fixed forever. There is no function here to change those. Okay. Abbas, you have a question? Abnav, let me see who has their hand raised here. I guess it's, yes, Abbas.
Okay, so you said once we deploy the contract and it's already deployed, nobody can change the parameters again, right?
Yes.
Okay, so does it mean that the reason we are writing our contract like this is so that we can reuse this particular contract?
The way we
Because
are writing it right now is because we can deploy different token sales with different parameters, like we did in a ballot. Remember, in the ballot, you could deploy 1, 2, 3, 4 ballots with different proposals, remember? And the votes that one ballot has nothing to do with the votes that another ballot would have. Does that make sense? Okay. So people, let's stop for a second here and ask ourselves a question. Do you feel this useful? This flow that you can pause, debug, you can do a console log. This can guide you to understanding all of those concepts, like we did to understand arrays and mappings and all, for you to understand what's going wrong with your smart contract. Instead of wasting hours of debugging, you can just come here in a very structured way and log things, debug things, and understand what's going on. Okay, this is the most important thing for us to have today and tomorrow, having this track for us to complete our smart contracts. Okay. Laurent, you want to ask something?
Yes, in your code, line 22,
Yeah.
you have dot read, and in my VS code, the dot read is underlined with a red line, and it said cannot read properties of undefined, and in brackets, reading ratios.
Okay. Maybe you have something like this.
Public, maybe it's public, right?
Yeah, I had this problem too. So we fixed the two things a while ago. We fixed this number, big number, And we also fixed the read stuff because we don't have read ratio here.
Okay.
We don't have any read functions. So when we put public here, now we have those read functions. I would need to compile everything, but then I would have the read ability here.
Okay. I'll try, and if I have other issue, I will let you know. Thanks.
Okay. And the test in line 25 is super easy to complete now. Can pick the same code. And what would they change here?
The price.
Price. This would check if the price is correct. Okay. Up to this test, we completed 2 unit tests, half of this deployment checks. Up to here, any questions? Yes, Johnson?
I am getting some errors for the test. I put in the chat.
Okay. So, but I would need to check if you have the same code. Maybe you want to check there on your side if you have the deploy contract fixture, if you change the parameters correctly. This is a very important part of the exercise for you to follow what's going on and try to make sure it's equal on your side.
I will check that.
But Johnson, any questions of what is going on here? Like you understand that we first apply the contract that we have here, and then we are doing those 2 tests to see if the variables that we are passing at the construction are the variables that we have in the contract.
Yeah, I understood that unit test. That's clear for me. Yeah. Yes.
Okay, good.
But I don't know when I compile, I got some errors. Yeah.
Yeah. Then maybe you check if you did the same steps, if you have those 2 variables on your side, if you build the construction. Okay, maybe you can do this.
I will check that. Yeah.
Okay, now I want suggestions for how we are going to do the token stuff. We are not going to inherit, okay, but we need to have ERC20 to use as a payment token and an ERC721 to use a collection. What should I do here for interacting, for putting this 2 contracts, like putting it somewhere in the smart contract? Maybe you want to open your mic and chat with me here. Might take a while for you to type things out, right?
Maybe the contract should be like payable, the token sale contract.
I should have payable functions. Yes, that's true. For us to receive payments, but this would come in this scenario, right? Just a little after.
Can we check if it implements a specific interface?
Yeah, we could, but remember the problem. If I say that token sale is ERC20 and ERC721, we are going to have problems, right?
What does it mean uses a valid ERC as a payment token?
It should have a payment token for it. It should have this thing here. It should have an ERC20 token configured there for minting those tokens and also for burning these tokens, right?
No, I mean the unit test itself is written as it uses a valid ERC as a payment token. So in this
it uses a valid ERC20 contract, something like that.
So the contract uses the contract. I have no idea.
Yeah, let's think on that together.
I think we need to first define an ERC20 token and implement it. And then make use of the symbol here for the, code, the name here in our contract. Is that wrong?
And
Sure.
define like a role, right? Like the role of someone.
Okay, I would need a role later for a mint. Yes, that is true. So I like the ideas. We are collecting an amount of ideas that would be important for the whole challenge itself. But let's go baby steps. How did we do that in the greetings invoker? Remember, lesson 2 or 3. We had a contra calling the other. Yes, Browns?
Okay, we use the import statement. That's is we wrote the is. That was where we use the parent contract with the child contract. So we now put is in between both of them.
Okay, let's see if we remember that. In lesson 2 or 3, I don't recall very well, we did an external call where we had a hello world contract, and then we had a greetings invoker that would call that smart contract, remember?
Yes,
One smart contract would call the other.
Use an interface. Use an interface.
Yeah, and do you remember what were the parameters that we used? We had a thing that started with a T.
Yes. Okay, the parameters, we only use external inside the interface. It's not a public. We don't use public in the interface.
Okay, let's start from 0. So let's think on this together, people. We want to have a way for the contract to call the other, like we did in the greetings invoker, remember? In lesson 3, I guess. And we were passing one variable, which is the name that starts with a T, that would allow us to do this relationship from one contract to the other. Okay. I just remember that I need to go for Target to buy some things for my wife. Okay. Just discard that thought. Do you all remember what was the name of that variable?
I mean, like the owner, the transfer ownership, is that what you mean?
No, people. We used a variable called target. Remember?
I don't remember that lesson.
Okay. Too many things. I guess I overloaded you all with information within this bootcamp. But do you remember the greetings invoker contract, right? And I would have a function like this: invoke greetings, and I would have an address of a target, and blah blah blah, sent here in the chat. Remember this? Maybe I'm tripping. Maybe I didn't do this example.
I don't think we had the example like that.
Javier remembers. Okay, yeah. So too much information, I know. Maybe I should go even slower here. We can have TokenSale.sol to interact with another contract just using one address as a target. For example, I can have an address, let's mark it as public, as the payment token, and I can have another address, let's mark it as public, as the NFT contract. The ERC20 and the ERC721. The address of the payment token and the address of the NFT. Okay. And whenever we want to call those things, for example, let's do it just like we did in the first week. I would I have the address of a hello world. Okay. And then if I want to invoke greetings function, invoke greetings, I would need to have a target. I don't need it anymore because the things is saved there. Let mark it as public. Returns a string in memory, and I would return the hello world interface, the hello world interface that I would have with this hello world address dot hello world. Remember, we did something very similar to this.
Yes,
Marco,
with an interface.
you have that same. Yeah, we would use
Yeah.
the interface for that now. So whenever we want to do something in the token, like do something with my token, I would have the I token in the token contract address, and I would have function something, and would return something here. Does this make sense? The same structure we did in the past, just exemplifying those external calls. We can do it now with this smart contract with the token sale, right? Okay. Question, Dante?
Yeah, so why do it this way? Because we're the address for the token contract address that we're using is going to be the Ether, or is it going to be the one we want to switch to? Or at that point we'd have to, but is that what you're doing? You're basically not putting the information into the contract, but bringing it in so you don't put a bunch of stuff in your contract?
Yeah, we can deploy it first. In future lessons, I'm going to show that there is a way to make the token contract address equal to a new ERC20, like that. I'm going to show that on future lessons that we can do this. Okay, but for today, it's not about saving gas here. Okay, this is more about the external calls itself. So what I'm going to do is having a token contract address and an NFT contract address. I know that is an address. I don't need to repeat the word address. And token contract and NFT contract. And I can say that the token contract equal to the token contract received in the parameters. The NFT contract equals to the NFT contract received in the parameters. Address this and address that. Okay. I'm going to deploy those first. I'm going to pass them here. And then I'm going to pass them here actually, and then I'm going to save them inside the smart contract. Okay. If I want, later I could even change this address of the token contract to something else, an NFT contract to something else. But for now, I'm doing one token sale that would have these parameters. Okay. Passing parameters in the construction is the same thing as we did in the ballot. The only complexity here is that we are passing now addresses. Okay. So take a minute to code this on your smart contract. You're going to do the test for this right now. And I guess we are going to stop at the constructor today, and tomorrow we pick up from this challenge doing the payments part, doing the minting, the burning. Okay. So now we need to pass two more parameters for token sale. I need to pass an address of a token contract and the address of an NFT contract. Okay. Let's do it wrong first. Let me pick the deployer account.address, which is wrong. And let me pick the other account.address, which is wrong. Those are not smart contracts. I know. I'm just passing some addresses. This is wrong. Okay. This is wrong too. Just passing some address just for this test to go. And then I want to test if I'm using a valid ERC20 as a payment token. Okay. How to do that? Well, the same way that we were doing the price, I can pick the address, the token contract address here. So const token contract address equals to token sale contract dot read token contract. Okay, the same thing that I did with the price, same thing that I did with the ratio. Now I'm doing here with the token sale contract. After all, this is just a variable. The only difference is that ratio and price as number are numbers and address is an address. But I'm just picking a variable here from the smart contract. Nothing new here, okay? I want to check if my token contract is an ERC20. What functions do we know from yesterday that an ERC20 should have, or even must have for working?
Balance of.
Balance of, yes.
Total supply.
Name is optional, but it's good to have total
Symbol.
supply, symbol. Okay. Let's pick total supply. It's not a very comprehensive test, but if my contract implements total supply, it should work, right? Here, I can, instead of deploying a new smart contract, I can use VM to get the contract at an address. We did that on we had that on the README of the lesson 5, if I recall. Let me see. If you don't remember how to do that on the lesson 5, in lesson 7. If you don't remember how to do that on the top of your head, that is no problem. We have that in the past lessons. So, no, yes, not in the lesson 7, sorry, in the lesson 8. At the end of it, here. Whenever we want to pick a contract in somewhere that we have deployed in the past, we can read the contract at an address. Okay, this is a function that we have with VM. Okay, we don't need to deploy that contract address again. I can just pass the contract address. With VM directly, we need to use the ABI for that. When using hot, when using, let me pick the documentation again to show that for you. When using hot with the VM, using TypeScript, there is a guide using VM here. We can read information from smart contracts just by attaching them. To have this documentation somewhere. I should have it somewhere. If I find it quite quickly here. This is deploying the contract. I want to get the contract at. I should have that in the documentation somewhere.
Might it be in the part where it talks about public client?
Client, test client, client options, contracts, get contract at here. So in the documentation, we have retrieving existing contracts. So the same thing that we did in lesson 8 here with the VM directly, whenever we use a smart contract directly with the VM by passing the address API, now we can use with hot VM by using this function get the contract at. So we just need to pass the contract name and not the whole API and bytecode and blah, blah, blah. So we can create our token contract there, our token contract instance. So const token contract, okay, this instance, as equal to awaiting VM get contract at. VM get contract at. So I don't need to pass the API and everything else. I just need to pass the name of the artifact, which here is my token. The name of the thing that I'm trying to pass is my token. And the address is token contract address. Okay. And then I can get the total supply, const total supply, equal to awaiting my token contract dot read dot total supply. And I expect total supply at deployment to equal to 0. Or I could expect that function not to fall, or I could say that to greater or equal greater than, yeah. Wait, what was the function again? To wait. Greater than equal, yes, ETTA, for being greater or equal to 0. In this situation, it's going to fail. Why? Because my address is not the address of a smart contract. So the contract function total supply returned the data 0x because I passed a wrong contract here. I passed, how to clean this up? I passed a wrong contract there in the fixture. I passed this wrong. Tomorrow we're going to start by fixing this, by putting a correct address here. And then I'm going to get this correct address from the smart contract. And then I can create a new smart contract. Instead of deploying again, I'm going to get the contract at using this hot function to get the contract at this address and try to pick the correct function of total supply here. Okay, that should answer your question. I mean, how do you write tests for that? This should be good enough for us to test if we're using a valid ERC20. Okay.
How do you know the name of the contract? Why is it my token?
It's not the name of the token itself. It is the name of the artifact that we have here. Okay, it is here on line 7. It's my token here.
That's from our previous lesson. Okay.
Yeah.
Okay.
I copied the project 5 for doing this. You need all of the files from yesterday's lesson. Okay. And tomorrow, you know what's going to happen already? Instead of picking this wrong thing, I'm going to first deploy the correct. Let me try and use AI for doing that quickly. The const token contract awaiting deployed. Yeah, exactly that. Okay, would be the my token. Let me see. My token. Yes, this is correct. I would need to pass some other parameters, and then I would need to pass the token contract here. You see, the copilot from Kusu got it correctly here. Okay, but we are out of time for today already. Let's not haste things. This is for tomorrow. We are going to do that slowly. I'm going to do a quick review on this too. And tomorrow we start from the same place, okay? The exercise for you to have the same code as I do, okay? So for future lessons, I will share the code, but for today, it's important that we exercise, we type this so we can remember this better in the future, okay? Thank you, people. Have a good one.
Could you share yesterday's code in GitHub? The complete token code.
Yesterday's code is there already, right? If we go for yesterday's README on the lesson
Okay, so I have to just connect it.
9, yes. You would have all of the code from here. The ERC20, the ERC721, then the changes we made here with this script, and then you can use that for today. Okay. And then you just copy. Thank you, people. Yeah, I just noticed that I'm not sharing my screen anymore. Sorry about that. So we have it all here on the lesson 9. Look. So my ERC20 and my ERC721, we have all of those contracts here. Okay. Good. Thank you, people. Bye-bye.